Alright, so now for the last part of the nervous system, the autonomic nervous system. Now think of the autonomic nervous system as being automatic. It controls your internal organs, and you don't have to think about it. Now you have to know that it controls our smooth muscle, cardiac muscle, and our glands. So there are two divisions of the autonomic nervous system, the sympathetic division and the parasympathetic. Sympathetic division, think what happens when you get angry, nervous, or scared. Your heart starts racing, your blood pressure goes up. So that's what the sympathetic nervous system is doing. But then it decreases the digestive system activity. And the parasympathetic does the exact opposite. It's active most of your life when you're not angry, when you're not scared, and it's just reducing your heart rate, blood pressure. But it increases digestion and elimination. Now, there's a little bit of a difference in the autonomic nervous system. The somatic nervous system, remember, that goes to the skeletal muscles. Only one neuron goes from the spinal cord to the muscles. But with the autonomic nervous system, there are two neurons. There's the preganglionic neuron, the first neuron, and the postganglionic neuron. And so we're going to learn that the preganglionic neuron releases acetylcholine and activates the postganglionic neuron. And then the postganglionic neuron can release acetylcholine or norepinephrine, depending on if it's parasympathetic or sympathetic. The somatic nervous system, we saw that the neuron releases acetylcholine to the muscle and the muscle is activated. With the autonomic nervous system, again, preganglionic neuron. Fiber is just another name for neuron. Preganglionic neurons release acetylcholine. Postganglionic neuron releases norepinephrine if it's sympathetic, or acetylcholine if it's parasympathetic. And so we're going to see that depending on the receptor that is on the organ that is responding to the neurotransmitter, the organ may either be stimulated or inhibited. So this picture is an overview comparing the somatic nervous system to the autonomic nervous system. So again, just one single neuron for the somatic nervous system activating the skeletal muscle. So that you're seeing at the bottom the autonomic nervous system, sympathetic versus the parasympathetic. And so you're seeing with the sympathetic, you have the preganglionic neuron. It releases acetylcholine. Ganglion just refers to the cell body of the postganglionic neuron. And the postganglionic neuron releases norepinephrine. Now, one more thing for the sympathetic nervous system. The adrenal gland is part of it. Adrenal glands are above your kidneys. The inside part of the adrenal gland is called the adrenal medulla. So here the preganglionic neuron can go and activate the adrenal gland, and then the adrenal gland can release epinephrine and norepinephrine. So just note the adrenal gland is just part of the sympathetic nervous system. Okay, and so then at the bottom you're seeing the parasympathetic one with the two neurons. Here, both are releasing acetylcholine. Sympathetic division starts from the thoracic and lumbar regions of the spinal cord, so it's also known as the thoracolumbar division. And so what we're seeing is you have the spinal cord here. The neurons are going to come out from the spinal cord and they're going to go through the ventral root and then onto the body. Now, on either side of the spinal cord, I like to think of this as kind of like an elevator. This is called the sympathetic trunk, and it's got these bulge parts here. These are the sympathetic chain ganglia. So what we're going to see is the preganglionic neuron comes out from the spinal cord. It's going to go into the sympathetic chain ganglion, where it may synapse with another neuron, and then the postganglionic neuron is going to come out. Okay, so the reason for this elevator, so what you're seeing is this is the sympathetic trunk here. On either side of the spinal cord, the bulge parts are the sympathetic chain ganglia. So the signal can go up or down this elevator to reach the organs in the upper or the lower parts of the body. And so if the information wants to go up to the heart or to the glands, it can use this elevator. Or if it wants to go down to the lower levels, it can use this elevator to go down there. Okay, so if the signal wants to reach an organ that is at the same level as where the neuron is coming out, the preganglionic neuron, which is the screen here, it goes in to the sympathetic chain ganglion or the sympathetic trunk ganglion. Here it synapses with the second neuron, the postganglionic neuron, and the postganglionic neuron will then go out to the body. Okay, so what I want you to know, the entrance into the sympathetic chain ganglion is through the white ramus. Okay, so here it says enter. And then this postganglionic neuron exits through the gray ramus. Okay, so this is if it's at the same level. Okay, so then next slide. If the information wants to go to a higher level or to a lower level, then it can go up and down this elevator. So again, you're seeing the preganglionic neuron. It's coming out. It goes through the sympathetic chain ganglion, up and down the elevator, and then wherever the signal wants to leave, then the synapse occurs with the postganglionic neuron. And so now you're seeing the postganglionic neuron then go out to the body. Okay, once again, the entrance into the elevator is the white ramus. The exit is through the gray ramus. Okay, as if that wasn't complicated enough, if the signal wants to go to the abdominal organs, to the pelvic organs, then there is this ganglion that is farther away from the sympathetic chain ganglion. So then this is where the synapse is occurring. Okay, so know that the collateral ganglion is where the synapse occurs if the signal wants to go to these abdominal organs. And so then this slide is just kind of giving a summary of what I just talked about. Either the preganglionic neuron can go into the sympathetic chain ganglion and then synapse with the postganglionic neuron, or it can go up or down the sympathetic trunk, or the collateral ganglia if the destination is the abdominal organs. Okay, then the parasympathetic division. This is also called the craniosacral division because some of the nerves are coming from the brain part and some of the nerves are from the sacral region. And so the brainstem refers to the cranial part, and then the S2 to S4, this is referring to the sacral. So really know those two here, and I put these in for reference. The nerves for the parasympathetic in the cranial region, oculomotor, facial, glossopharyngeal, and also the vagus. So those are the cranial parasympathetic neurons, and also the sacral neurons are carrying the parasympathetic information. Okay, so on this picture we're seeing cranial nerves at the top. So there's the oculomotor neuron. The oculomotor neuron goes to the eye. Facial and glossopharyngeal, they go to the glands. And we're seeing here the longest cranial nerve, the vagus nerve. This starts out from the brainstem and goes to your internal organs. And then at the bottom, you're seeing the sacral nerves going to the reproductive organs. Cholinergic neuron just means a neuron that releases acetylcholine, and an adrenergic neuron means that it releases norepinephrine. Alright, so I like making a diagram to put things into perspective for you guys. So what I'm going to do here, S for sympathetic. Sympathetic neurons, here we have the two. The first one is the preganglionic, and the second one is the postganglionic. The preganglionic neuron releases acetylcholine, and the second one releases norepinephrine. Okay, so then let's say that this is the heart. Norepinephrine then goes to the receptors. Receptors are at the top of the channels. Norepinephrine for the heart causes sodium to enter, and sodium causes depolarization and action potentials in the heart. Okay, but then if we compare this with the parasympathetic, okay, so both sympathetic and parasympathetic go to the same organs. First one, no matter what, releases acetylcholine. The second one releases acetylcholine as well, if it's parasympathetic. Okay, so now here the acetylcholine opens the channels, and this allows chlorine to come in and making it more negative on the inside, so it reduces the chance of an action potential. And so what's happening here, the sympathetic nervous system is increasing the heart rates by causing sodium to enter, and the parasympathetic decreases the heart rates. Okay, but then if we compare this to the digestive system, so let's say that this is the stomach, sympathetic here. Okay, so now they actually open different channels. This one opens the chlorine channels, and the parasympathetic one opens the sodium channels. And so now you can see that the sympathetic nervous system decreases the digestive activity, and the parasympathetic nervous system increases digestive activity. So here, both of these are cholinergic neurons. This one is adrenergic because it releases norepinephrine, but this one is also cholinergic. And so the same thing on the other side. Now, they call the receptors where the neurotransmitters attach to these also cholinergic versus adrenergic. So here, because norepinephrine attaches to this receptor, this is called an adrenergic receptor. And the other one, because acetylcholine attaches to it, this is called a cholinergic receptor. Okay, so we don't have to know all the things that are on this graph here, table here. So if acetylcholine attaches to a receptor, the receptor is called cholinergic. And if norepinephrine or epinephrine attaches to a receptor, it's called adrenergic. And so beta 1 adrenergic refers to the heart, beta 2 for the lungs, beta 3 for the adipose. On your study guide, I had that question. The beta blockers, adrenergic beta blockers, they stop norepinephrine and epinephrine from attaching to the receptors and opening channels. So beta blockers are stopping or inhibiting the sympathetic nervous system effects. And so this would be for in the medicines that are given to heart patients. Okay, so just like with the other synapses, you have to get rid of the neurotransmitter if you want the signal to stop. So the enzyme acetylcholine esterase breaks down acetylcholine in the synapse, and then norepinephrine is broken apart by monoamine oxidase instead. Okay, that is the end of our chapter.